Hello students, I know you miss me, but here we are. At least you get the experience of hearing my voice as we go through this remote learning experience together. So today we're going to be going through examples of how we can graph sine and cosine functions on the coordinate plane. So essentially what we'll be doing is we'll be taking the unit circle and unwrapping it and then plotting it on a coordinate plane to see the types of graphs that we can generate. Two things that may be useful to you as we go forward to have handy. First is to have a completed unit circle. We'll refer to that at times. And then equally useful might be to have a calculator set to radian mode. So if you want to enter some of these values to be able to evaluate them on your calculator, although I'll be doing that for us here going forward, that might be handy to have as well. So what you see in front of us is a table of values. The x values, the input values, are our angles from the unit circle. You can see it starts from 0, goes up to pi over 6, pi over 4, pi over 3, and then continues through the first and second quadrants in the first column, and then we continue on in the second table with the values of the third and fourth quadrant angles. And so what we will do is we will take the values that we're going to generate in the table and we're going to plot them on the coordinate plane that's on the right. And so you can see on the x-axis it's labeled out for us already in radians. So we're going to be graphing our angles, our inputs, our x values along the x-axis, and then the outputs of the function are going to be graphed along in the y direction. And so for sine, when we pull those values from the unit circle, those are the y coordinates. Since the sine values, as we know from the unit circle, we can find those by just taking the y coordinate of the point that's associated with that angle. We can also, of course, do this on our calculator. So either from the unit circle or by typing it into our calculator, we know that the sine of 0 is 0. If we look at the y coordinate at 0 on our unit circle, it's 0. Type it in, it's 0. Pi over 6. The sine of pi over 6 is 1/2, or 0.5. We'll stay with decimals here. And so as we go, we can go ahead and plot these points on the coordinate plane. Now on the y-axis, I'm going to scale it with 1 at the top and -1 at the bottom. We're not going to go above or below those values because that's the maximum and minimum values that sine can hit. If we look at the y coordinates on the unit circle, that is our limit. On the upper end, it's 1, and the bottom limit is -1. So carrying on, we can plot those points there. So we've got 0, 0. We go to pi over 6, which is going to be not quite at that middle tick mark there, which is at pi over 4. We're going to be just a little bit to the left of it. Pi over 4, if we look at our unit circle, the y coordinate is root 2 over 2. So as a decimal, that's 0.707. Now we're obviously not going to plot that super precisely, but if we're counting by 0.25, so it's those tick marks along the y-axis, we're going to be a little bit below that third tick mark, which is 0.75. So we'll put that mark right about there. Pi over 3, if we look at that on the unit circle, the y coordinate is root 3 over 2. So that translates into 0.866 if we use our calculator. So now we're a little bit above that 0.75 line. And then finally, we're going to top out at pi over 2. The y coordinate is 1. And as we continue to work our way around the unit circle, the y coordinates start to get smaller. When we go to 2 pi over 3, we get the same thing as we have at pi over 3, which is that 0.866. So if we plot that, we're right about there. 3 pi over 4 is the same as pi over 4. The y coordinate is that root 2 over 2, 0.707. So we're right about there. At 5 pi over 6, the y coordinate's 1/2, or 0.5. And then finally, when we rotate all the way over to pi, our y-coordinate is back down to 0. And so what we have here is the graph of not a kind of upside down V. It's not like an absolute value graph, but instead it's a curve. And it's a curve that looks something like this. So you can see it rises up, it tops out at pi over 2 comma 1, and then it drops back down. And if we continue to plot the points into the third and fourth quadrants on our unit circle, you can see those angles in the second column, those y-coordinates on the unit circle are going to be negative. So that means our y-coordinates on this graph for those values are going to be negative. So we have the repeat here of pi is 0 again. 7, now we continue. 7 pi over 6 is negative 1/2. 5 pi over 4 is negative root 2 over 2. 4 pi over 3 is negative root 3 over 2. And then finally, at 3 pi over 2, we hit the lowest most y-coordinate, which is negative 1. And so if we were to plot those points individually, it would create the same type of shape as what we have already. So we're going to bottom out there at 3 pi over 2 is negative 1. And so we've got the curve extends until we hit the bottom here. And then for the remainder of our pathway around the unit circle, we start to repeat those same values again. At 5 pi over 3, we're negative root 3 over 2. At 7 pi over 4, we're negative root 2 over 2. At 11 pi over 6, we're negative 1/2. And then we get back to 2 pi, which is the same as 0. And we're back to 0. And so then we get to 2 pi. And so what we have here is a full sine wave. So this is what we call a periodic function. Because if we were to continue, if we were to extend our chart to go past what's on the unit circle and start going around again with those larger coterminal angles, the graph would just repeat itself. We would get this exact same shape. We would get another cycle that would extend and do the same thing going forward. Or we could do the same thing and go backwards. It would be the exact same shape as that purple graph, just extended backwards as well. And so the key points that we want to be familiar with graphing on these, we don't have to plot out each individual point once we understand the kind of repetitive nature of these. Instead, the key points that we want to look at are where the cycle begins and ends, when is the graph in the middle of its cycle, and then when is it at these maximum and minimum points. And so the distance along the x-axis that the graph takes to complete this full cycle is called the period. And that period for a sine wave, and as we'll see momentarily for a cosine wave, is 2 pi. And so what I can do is I can go ahead and extend this graph backwards to do the exact same thing in the negative direction for all these angles. So I can go back 2 pi before the start of that original graph there, and so I can put a dot there at negative 2 pi. I can see that halfway between the start and end of the cycle, the graph was at 0, so I'm going to put a dot at negative pi. And then halfway in between those first two zeros, we're at a maximum, and then halfway in between the second and third zeros, we're at a minimum. And so then you can see that I can go ahead and extend that graph exactly the same. So those two parts of the graph, what's to the left of the y-axis and what we originally graphed to the right, are exactly the same thing. And so we can repeat this process for a cosine graph. What we're going to find is the graph looks very similar to what we just generated with the cosine graph. It's just going to be what we call out of phase. So the starting point and the ending point of the cycle is not going to be at 0 like it was for sine, but instead it's going to be at the highest point at 1 for cosine. We'll see that as we start to roll through the chart, the table of values. But essentially the graph is the same. It just starts at a different point in the cycle. And so remember from our unit circle, cosine is the x-coordinate. So we're going to use our angles again as our inputs. But now for the outputs of the function, we're going to use the x-coordinates from the unit circle, since cosine is tied to the x-coordinate. And so when we're at a 0 degree or a 0 radian angle, the x-coordinate is 1. So again, right away, you can see immediately that we have a difference. So I'm going to scale the top as 1, the bottom is -1. And so now, instead of starting, let's try to actually hit the dot there, instead of starting at 0, our graph is going to start at the top. It's going to start at 1. But then all these values are going to be very similar to what we saw previously. The cosine of pi over 6, the x-coordinate at pi over 6 is √3/2, or 0.866. At pi over 4, the x-coordinate's √2/2, so it's that 0.707 number again. At pi over 3, the x-coordinate is 1/2. And then by the time we get to pi over 2, the x-coordinate has dropped all the way to 0. And so if we were to plot these points individually, pi over 6, we're right about there. Pi over 4, 0.707, we're going to be a little bit lower. We can probably place that a little better, or maybe not. There we go. By the time we get to pi over 3, we're at 0.5. And then finally, when we get to pi over 2, we're at 0. So hopefully we can see that this is kind of like the downward slope of the graph that we, similar to what we created before. If we extend the table of values, our table continues into the second quadrant, so our angles continue into the second quadrant. So our table in the y set of y values is going to be negative. So we're going to have negative 0.5, negative √2/2, negative 0.866. And so finally we get to pi, where the x-coordinate is -1. And so we've dropped all the way down to that lowest value right about here. And then if we continue around the unit circle, the x-coordinates are still negative, but they're going to be getting less negative as we rotate through the third quadrant. So 7 pi over 6, 5 pi over 4, 4 pi over 3, we're going to get all these same values. Negative √3/2, negative √2/2, negative 0.5, negative 1/2, and then finally at 3 pi over 2, we're back to 0. If we look at the x-coordinate on our unit circle, we're back to 0 by the time we get to 3 pi over 2. So we've crept back up. And then again, as we rotate through the fourth quadrant, the x-coordinates are growing. So we have our 1/2, √2/2, √3/2, and then finally when we get back to 2 pi, it's the same as 1. We're back to the top of our graph. And so what we have here is the exact same curve. If we extend this going backwards like we did for the sine wave, so again, focusing on these key locations here, where the graph is at either a maximum or a minimum at the zeros, the graph took through a period of 2 pi along the x-axis to complete its full cycle. And so I can extend backwards. I can go back 2 pi along the x-axis. And so I'm going to start the previous cycle 2 pi previously at -2 pi. Halfway through the cycle, we can see that the graph is at the bottom. So that's going to be at -pi. And then halfway in between those maximum and minimum points, the ones and negative ones, the graph is going to be at 0. And so then I can use that as the framework to sketch the previous wave of my graph. And so this graph will continue to extend likewise in both directions. But hopefully if I flip back here, we can see that the shape of these two graphs is exactly the same. It's just one starts at the top and starts down and then comes back up. That's the cosine graph. The sine graph starts at 0, goes up, comes down, goes into negative territory, and then comes back up.